One of the topics in Mathematics Standard 2 is nonlinear relationships. What is a nonlinear relationship? Put simply, it's a relationship between two variables that is not a straight line. In this picture here on the left, the input variable x and the output variable y are related by a straight line. This is called a linear relationship. A nonlinear relationship is when the two variables are related by something other than a straight line, for example, by a curve. There are millions of different nonlinear relationships that can occur, but you need to know about three types. These types have curves that are called a parabola, an exponential, and a hyperbola. You need to be able to recognize the shape of the graph for each type. The graph might move up or down, or across, or be flipped, but it will always keep the same basic shape. The parabola has a symmetrical sort of U-shape, like a smiley mouth or a frowny mouth. Parabolas always look like one of these two graphs. Parabolas are also referred to as quadratics. A parabola always has either a minimum value or a maximum value, and the arms of the parabola always go off towards either positive infinity or towards negative infinity. The exponential curve either starts off very flat on the left and then rises sharply and heads off towards positive infinity, or it starts off very large on the left and decreases steeply, then flattens off and continues to decrease, but very, very slowly. In these two graphs, the exponential curve gets closer and closer to the value y equals 0, but it never actually gets there. The y value for these curves is always positive. It never actually reaches 0, and because of this, the line y equals 0 is called an asymptote to the curve. An asymptote is a line that a curve approaches but never quite reaches. Reciprocal relationships, or inverse relationships, are represented by a type of curve called a hyperbola. The full hyperbola has two branches located in opposite quadrants on the graph. The arms of the parabola head off towards positive infinity or negative infinity, and the x and y axes form asymptotes of the hyperbola. The arms of the hyperbola get closer and closer to 0, but never actually get there.